So this is section 3.1 about complex numbers, okay? And you probably remember this from high school. When we have the square root of -1, like we do up here in this first thing, remember that's defined as I. So when I have I squared, that's, the square root of -1 times the square root of -1. Well, that's just going to be -1. So I squared is -1. And then I start using that when I do I to the third, and I can simplify I to the third as I squared times I. So then remember I squared we just said was -1, so this is negative I. And then when I do I to the fourth, I squared times I squared, well that's just -1 times -1, which is just +1. So every time I get a multiple of 4, it goes back to +1. Okay? And everything can be simplified to either I, -I, 1, or -1. So when you have these, and it's very cyclical, as you can see over here, when I do I to the fifth, I can think of this as I to the fourth times I. Well, I to the fourth was 1, so 1 times I is just I. I think I'll just write I. Okay, same way with I squared. I squared is I to the I to the sixth, which is I to the fourth times I squared. Well, that's 1 times -1, which is just -1. And then I to the seventh, I can think of that as I to the fourth times I to the third. I to the fourth was 1. I to the third was -I, so that's just -I. And I to the eighth is just 1 again. Okay? So this continues this lovely pattern. I to the ninth is going to be I to the 10th is going to be -1. I to the 11th is -I, and I to the 12th is going to go back to 1. So any multiple of 4 is going to give us 1. So if you have something like I to the 14th that you have to simplify, I mean, you could just like keep going and going and going, but it's kind of silly. So think of the greatest multiple of 4 that's less than 14. So I think 12 is the greatest multiple of 4. So I to the 14th is I to the 12th times I squared. Well, I to the 12th is just 1. I squared is -1, so that's just -1. If you have I to the 35th, so the multiple of 4 that's smaller, the biggest one smaller than 35, I think is 32. So I to the 32 times I to the third. I to the 32 is 1. I to the third is -I. So 1 times -I is just -I. So you have to be able to simplify those fun things. Okay, and why do we have this? So that we can simplify the square root of -6. It is no longer not able to do. We call this I times the square root of 6. This is supposed to be the square root of -8. So I would simplify this as the square root of -4 times 2, and the square root of -4 is just 2i, radical 2. Now you can write it that way. Technically, I probably should write 2 square roots of 2 times I, because the I usually goes at the end, but it doesn't really make any difference. Sorry, I'm kind of grovelly. The square root of -16 is just 4i, right? Okay, so no big deal. And then over here, I think I have the square root of -4 would just be 2i. Okay, so we do have real parts and imaginary parts. I'll change colors because now I'm in the purple mode. So not that it really matters for this, but if we end up with just a bi, that's the pure imaginary. And when we have b for 0, it's a pure real number. So a plus bi is usually how we have to write things. And so it's no big deal. We just have to pay attention. All right, so then we, of course, have to do arithmetic. We have to add, subtract, multiply, and divide. So, but adding and subtracting is no big deal. It's It's not like any other letter. It's the same as an x. So I would combine my like terms and say 3 plus 7 is 10, and positive 4 minus 2 is plus 2i. So that's no big deal. If it's a subtracting problem, I would probably first change it to addition, change my signs. So now I have 6 plus 2 makes 8, negative 3 minus 5 makes negative 8i. Again, no big deal. All right, when we multiply, it's also not a big deal, but we do have to remember something. I'm going to FOIL this, just like I do the other things. So 4 times 1 is 4. 4 times negative 3 is negative 12i. Positive 2i times 1 is positive 2i. And then positive 2 times negative 3 is negative 6i squared. But this, because I squared is negative 1, negative 6 times negative 1 is positive 6. This is where it differs from regular letters, because I squared means something. So now I have 4 plus 6, which is 10, and then minus 12 plus 2 makes minus 10i. Okay, so just be careful of that on the end. I have another one over here. So 7 times 8, 56. 7 times minus 4i is minus 28i. Minus 3 times 8 is minus 24i. And minus 3 times minus 4 is plus 12i squared. But remember, I squared is negative 1, so that's negative 12. So 56 and negative 12, I think, is 44. And then negative 28 minus 24 is minus 52i. Okay? Now we do have the fun things with conjugates. When we have one's a plus and one's a minus, those are conjugates. Remember, magic happens when we have that, because I end up with the middle terms canceling away. And that's very important, that the middle term cancels away and that I remember that. So that's going to end up with 0. Notice that all the i's are gone now, because this is like positive 4. So this whole thing turns into just a real number, which is 13. And that's important when we divide. So let's practice over here. I'll change colors because I can. So 5 times 5 is 25. 5 times negative I, negative 5i. This is plus 5i. Notice again they're canceling out. And then minus I squared. So these are gone. And minus I squared is plus 1. Right? Minus a negative is plus 1. So that becomes 26. So that's super important when I divide. Because remember, there's that ever popular rule, you're not allowed to have a radical in the denominator. So when we do this, we always multiply both numerator and denominator by the conjugate of denominator. Okay? We don't really care about the numerator, we just care about the conjugate of the denominator. So in this instance, 4 plus 3i, the conjugate is going to be 4 minus 3i. And to keep the value of the fraction, I have to multiply by a form of 1, so that means I have to multiply the top by 4 minus 3i also. Okay? And then I FOIL it, so 5 times 4 is 20. 5 times minus 3i is minus 15i. Minus 3i times 4, minus 12i. Minus 3i times minus 3i is plus 9i squared, all over. And because it's a conjugate, I know those middle terms are going to go away, so I'm not even going to write them. I just am going to go 4 times 4 is 16, and positive 3i times negative 3i is minus 9i squared. And then I say, oh yeah, this right here is negative 9, so 20 minus 9 is 11, and then minus 15 minus 12 is minus 27i, and then on the bottom, this is positive 9, so 16 plus 9 is 25. Now, this answer is okay with me, but you may have to put it in A plus BI form, which means you need to separate the fraction into 11 over 25 minus 27 over 25i. That's all it means. okay? There's one more here. And again, you can stop this video and redo it and watch it and blah, blah, blah if you want. So the conjugate of this denominator is going to be 2 minus 3i. So I multiply the top also by 2 minus 3i. And this one's a little bit easier because I can just go 5 times 2 is 10 minus 15i. And then the denominator is 2 times 2 is 4. The plus 6i and minus 6i is going to go away. So minus 9i squared. And so minus 9i squared is plus 9. So 4 plus 9 is 13. So I have 10 minus 15i over 13, or I can call that 10 over 13 minus 15 over 13i. Okay, I'll make another